Welcome to our demonstration video. Meet our team, Asude, Doğa, Furkan, Eser, and Utku. The system consists of three main parts: classification using CNN, identification using SIFT, and web design. We will start by examining classification. Convolutional neural networks used in classification are in principle deep neural networks with high confidence rates and high accuracy. First, we download the weights of the network from an open source named YOLO. Then we pass the input image through the architecture. Lastly, we detect which class the object belongs to and locate its position for later usage. Here we see a slowed down version of our system detecting a dog. Detection is done with 100% confidence. Here we see the same for detecting a cat. Detection is done with 97% confidence. Now, let's take a look at some statistics. Classification is executed in approximately 0.3 seconds. Average accuracy is 81%, which is correct detections over total predictions. Average confidence is 84% for cats and 79% for dogs. Detection distance is approximately 5 to 180 centimeters. We will now examine identification, how it works, case studies, and test results. ORB, Oriented Fast and Rotated Brief, is an open-source alternative to SIFT, Scale Invariant Feature Transform. SIFT is a key point detector and descriptor which is used in object recognition. ORB is less affected by noise and has similar matching performance. For the identification process, first we create the database. This process relies on matching the input image's SIFT vectors to images registered in the set. Either Flan or brute force matcher is used to do so. Second is identifying the cat. This is determined by choosing the most alike vectors from the dataset using our k-matching algorithm. Lastly, optimization is done to reduce the dataset size and speed up the process. Here we see a newcomer cat being registered to the dataset by extracting its features. Here we see the previous cat has visited our system again. Now we see that the system has recognized the cat using the pictures taken earlier. In these two images, we see the feature extraction of the new image and the matching to the older image. Now let's look at the test results. In this graph, the x-axis is the number of distinct cats registered to the dataset. Y-axis is the time for convergence in seconds. While the blue bars represent the unoptimized case, the orange ones represent the optimized case. This graph shows the effectiveness of optimization. The execution time has reduced significantly since the database is no longer clustered. This is a similar bar graph, but now the y-axis represents the accuracy. We see that the accuracy has slightly decreased for the optimized case, but this trade-off is worthwhile in general identification performance. So far, we've seen that the system successfully classifies cats and dogs, identifies newcomer cats, and recognizes if the cat visits the system more than once. Now, let's take a look at the user interface of the system. First, let's discuss the backend. The interface was implemented on a Python framework called Flask. Flask is a micro-web framework. It is classified that way because it does not require particular tools or libraries. In the devices page, we see all current devices. One is installed in OTE and the other three are in shipping. When we click on a device, we see all cats registered to it. Changing the name of the cat, adding a photo, and adjusting its meal are all customizable features. We also see some device information. We can turn the device on or off, see the battery charge, remaining food percentage, and the last refill date of the food reservoir. When we click on a cat, we see its name, how much grams per meal it consumes, and the last time it was fed. Since this cat was recently added, there is no information at the moment. After a while, we start saving data on this cat. Its name is Jem and he consumes 200 grams per meal. It was last fed 12 hours ago. Here is Jem's recorded data over a month's period. Furthermore, we can edit these from the account section. We can also automatically turn the device's LED lights on and off by entering a time from this page. This concludes our demonstration video. We've covered classification, identification, and user interface. I hope this video was informative. Feel free to check out our website from the following link. Thank you for watching.